in depth into the basics and the intermediaries to reach these advanced topics, but we'll try our best. Okay, so having said that, if some of you are already familiar with Python to a good extent, you might find this a little boring. So you decide whether to stay on or do something better. And others, what my experience working with network engineers has been, every network engineer at some point or other in the last few years, they would have tried their hands at Python and covered the basics a couple of times and then given up. Right. So my job here is going to be to rekindle your interest and ensure that you stick on and then learn it. Right. Because it's one useful skill that you must have. Okay, so why this Cisco is pushing us so hard to learn programming is, if you see the way networking has been changing, right? Everything is becoming like software defined. APIs everywhere. There are APIs. There is an integration that is needed, which means there is a good amount of scripting that would be required. Scripting as in, not exactly scripting, a little more than scripting, right? Which cannot be achieved using the scripting languages like Linux shell scripting or PowerShell scripting. And so a little bit of programming is what is required. So that's why Cisco has been pushing hard. Moreover, the way Cisco has been, of course, I'm just taking example from Cisco. This is applicable very much to any other vendor. Right? They all are building devices, building appliances, building applications, building ecosystem, bringing all of this together. Right? So, which means there is a lot of integration which is required between Cisco's products, multiple platforms and products, which means they will not be able to sell these products to the customers unless there is a good skill set in the market with these technologies. So that's why Cisco has been pushing so hard. Okay, so ultimately the takeaway is you have to, whether you like it or not, you have to learn at least one programming language, and Python is your best choice. Why it is so, we'll just see in the coming sessions. Okay, so before starting, right, people talk about programming, coding. So what is a program? And we should understand what is a program. Program is nothing but a set of instructions which we give it to the computer to perform a specific operation using some data. That's what we do throughout the day, right? Whenever we are interacting with the system, we are giving instructions to the computer in some way or other, and those instructions are manipulating some or other data. But programming is a more organized way of doing things, a more efficient way of doing things in a more persistent manner. When this program is executing, the raw data which we are passing as input to the program gets processed and some desired output comes in. And these programs are typically written in high-level programming languages which are close to human languages that we speak. Yes, very much. Python is like undercurrent. It flows through the entire lab, is based on Python more or less. Okay, these programs are written in what we call as high-level programming languages, as opposed to the low-level programming languages, which were there a few years back. Now also they're there, like Foxtrot, COBOL, C, this kind of things, which are very close to the hardware. High-level are like they are more and more like human readable, human understandable languages. For instance, like Python, Perl, these kind of things. Right. Now, these programming the instructions which we write in these programming languages are converted into machine understandable low-level language and then executed on the machine. That's what programming is all about. You give a set of instructions in a high-level programming language, and there is some program in between which converts this high-level language into low-level language, which can be understood by the system. Now, what is Python? Python is an interpreted, object-oriented, high-level scripting language which can be used for general-purpose programming. Right? So I tried to cram in all the features of Python into this one single sentence. It is interpreted, it is object-oriented. What do you mean by interpretation? What do you mean by object orientation? I'll just come to that in a minute. It is a high-level scripting language, which means the kind of language that you write while that you use while writing code is more like you're conversing with your friend. Okay? And it is a general-purpose programming language, which means you can build any type of applications in it. You can use it for network automation. You can use it for artificial intelligence, machine learning. You can use it for building web applications. You can use it for building UI applications. That's what we mean by general purpose programming language. As opposed to, let's say, we have SQL, structured query language. It is specific to databases. And let's say you have packages like MATLAB, right, which is specifically for scientific computing. And so unlike these, which are built for specific purposes, there's a general purpose programming language. That doesn't stop us from using it for our scripting purposes. Right? What do you mean by scripting is, scripting versus programming is, in scripting, your aim is to quickly write code to automate your day-to-day tasks. You won't be bothering about how efficient your code is, how it is going to be used in the long run, how extendable it is. All those things you won't bother about. You have a task at hand. You quickly want to automate it so that you don't have to do the task manually again and again. That's what scripting is. You quickly write, pick up a programming language or a scripting language, you automate it and put it aside. You won't bother about how efficient it is, how easy it is to extend it, and so on. Whereas the concept which I said will be applicable to programming. If you are writing coding, if you are doing coding or writing programs to solve a problem, you have to keep these things in mind. Right? How efficient your programs are, how easy it is to modify it tomorrow, how easy it is to extend it so that something else can be done by this program. So that's the difference. Object-oriented means typically when we are solving a problem, right, we focus less on the object, less on the thing that we are trying to solve, the problem that we are trying to solve, more on the tools. Right? You would have seen in real life also, if you want to do something, we generally tend to focus less on the actual problem and start fretting more about the tools that we are using to solve the problem. So that's what has been happening in programming also. So the focus has now shifted from the tools to the actual problem itself. So the problem which is at hand is perceived in terms of real life objects. You have a banking application which you want to build. You start thinking about what makes up a bank. What are the things that people expect to do? Who are the entities that are going to be there? Right? You have a bank employees, you have accounts, you have customers, which will all this put together. So these are all different objects that make up a bank. You have a healthcare application, right? You have hospitals, doctors, pharmacists, patients, then appointments, diagnostics. These are all the objects, different objects that make up a healthcare application. You take networking application, you're talking about devices, right? Interfaces, networks. These are the objects that make up your domain, networking domain. So object-oriented programming will help you to think about the problem in terms of objects rather than about code. So you start treating your, let's say, network device as an object. What are the different objects that make up your application, like routers, switches, firewalls? What do you want to do with them? Okay? You want to configure them. What are the actions that you want to do? You will enable certain rules on the firewall. You will open certain ports. You will configure the network devices. Those network will and so on, right? You have a VPN, you are applying policies, you are setting rules, and so on. So these programming languages will help you to think in terms of the real life objects and then code accordingly. Okay? So that's what we mean by object oriented. Finally, the interpreted, right? Now, programming languages, as I said, right? You write instructions in a high level language, which are then translated into low level languages. Now, who is doing this translation? So there is some guy in between, or some other software in between, right? Now, there are two types of softwares in between. One is compiler, the other one is interpreter. Compiler. So based on these two, the programming languages are broadly classified into compiled languages versus interpreted languages. Compiled languages behave in a certain different way. Interpreted languages behave in a slightly different way. So in compiled languages like Java, C, these things, what happens is you write code, it is taken and you give it to compiler. Compiler takes it, he goes through the entire code first to see if you have made any mistakes, like structural syntax errors, right? While writing, have you made any mistakes? You forgot to follow certain rules, certain best practices. It checks for all these things and throws out some things called as compilation errors. So again, you have to rectify those compilation errors. Then compilation is successful. Then an intermediary bytecode, which means somewhat closer to machine language code, is generated. So an intermediary file gets generated called as bytecode. Then this bytecode is taken by the underlying runtime environment and it gets executed. That's how compilation works. Whereas interpretation works like, there is nothing, it doesn't go through the entire program. It just looks at the first line, takes it, executes it. Takes the second line, executes it. Third line, executes it. So it starts from top, starts going down, and takes each line and just executes it without creating any intermediary bytecode and things like that. Why these two are created? Why it is so? There are various reasons, right? People thought, okay, in some cases compilers would perform better. In some other cases, interpretation would work better. So we don't have to worry much about it. The way it is the way it is. Python is an interpreted language. Not strictly so. If someone who is here who is very good at Python fundamentals, you might disagree. Internally, things happen a little differently. But for all practical purposes, as we are going to see, it is a interpreted language, right? Irrespective of what happens at deep down at the core. At a high level, it is an interpreted language. So, which means you give certain instructions in a file to Python. It just takes those instructions and starts executing them, starting from the top. Okay, as I said, it has wide range of applications, ranging from web development, scientific and mathematical computing, desktop graphical user interfaces, etc., etc. And some factual information on who built it, when it was released first, and so on. Okay. Now the burning question is, why Python? Why not something else? Right? That's because traditionally Python has been very easy for people to pick up and learn. Right? When other programming languages were very somewhat complex, and people from the scientific community, people from other domains researchers. They thought, okay, they need to automate some of their tasks, so they need to learn at least one programming language. They went to the one most popular at that point of time, which is Java. They got scared looking at the Java syntax and the underlying fundamental concepts, the complex concepts. Then they started looking at alternatives. They considered some other alternatives like Perl, etc., which were, if sufficient, for basic automation, but were not going beyond that. Then they came across this Python, which was very user-friendly, very easy to learn, very easy to start using. So they started developing their automation. They started using Python to solve some of their problems in their domain. Slowly, they ended up with so much of code, which they thought, okay, we'll expose these as Python libraries to be used. So that's how you see the huge amount of third-party libraries that we see today for like you have in networking, you have NetMiko, Paramiko, Napalm, Scraply. So many things are there which are used for network automation. All these were born like this. So there were some networking experts who were not very good at programming. So they took up Python. They could learn it easily. And with their combined, the programming knowledge that they gained by learning Python, combined with their networking expertise, the result is all the libraries that you see. Right? So they started contributing like this. So slowly the number of the ecosystem grew, the support system grew. And it has become like de facto programming language of choice for various domains, right? You take AI/ML, they prefer Python. You take networking, they prefer Python. Slowly, even for the web application, even for enterprise application development, people started preferring Python. Okay, so it's a great choice for network engineers to add programming to their skill set. Python is a great choice. And not only that, even the network device vendors have been actively pushing Python, right? Cisco supplies Python on some of their devices. Okay, so I guess that's pretty should be convincing enough for you guys to take Python seriously now. Okay, assuming that you have taken seriously, how do we go about it? What do we do? What is the first step? Right? First step is to install Python, and luckily we have this Cisco CWS, which means Python is pre-installed on it. It comes pre-installed with Python, so you don't have to worry about installing it. But if you still have your Windows laptop, Linux laptop, Mac OS, Playbook, Mac devices, etc., you still want to go ahead and install it, I've given the instructions. On Windows, it's pretty easy. Go to this, download the Windows installer, and then follow the installation wizard. You're done. Even on Linux, it's pretty simple. I've given this link. You can follow the instructions. Normally, we can directly use package managers like apt in case of Ubuntu. So it's like sudo apt update and then sudo apt install Python 3. But in case if it does not work, if it fails, there are detailed steps to be followed, which are given in this. Right? You need to install certain prerequisite software. You need to add Python repository to your local repository, sync it, and then you'll be able to install from specific repositories. Okay. Now, why I said Python 3 is, so this could be a little confusing for people who are getting started. So sometimes when you, like on your Linux or Mac systems, if you see that Python would already be installed, right? And when you try to check its version, you see that it's 2 point something. So primarily there are two major versions of Python currently: Python 2.x and Python 3.x. Right now, why it is so? Why there is this confusion? Why can't they just have one version? I mean, normally when a later version comes, we just forget about the older version, right? Unfortunately, in case of Python, that did not happen because, as I said, Python started off with a different purpose in mind. It started off as a scripting language, then it slowly grew into what it is today. Because of that, at some point, right, it started as Python 1 something, and then Python 2 became very stable, very solid. People started using extensively, built so many applications on Python 2. And then it was time to switch gears and get modernized to be able to support the modernistic software development. But then they realized Python 2's architecture was not supporting that. So to re-architecture Python 2 would take great effort. So then they decided keep Python 2 as it is and start building something new. Let's call it as Python 3. Now, the problem is Python 3 is not backward compatible with Python 2, which means the programs that you write in Python 3 will not work on Python 2. And the other way, right? The code that you write for Python 2 will not work on Python 3. Because of this, there's a bridge. And they cannot just junket Python 2 because it is so popular. There are so many applications which are built on Python 2, which continue to run. So this led to the confusion. So most of the times, the Ubuntu and Mac devices come pre-installed with Python, which is Python 2. Right? So if you can go to the terminal, your Linux or Mac, and check Python -v or -- version. Both of them work. This has become a pretty standardized way to check version of any software that you're using, -- version. So if you see 3 point something, you're good. If you see 2 point something, then you need to install Python 3. Instructions for which is given in these links, which I've given in the guide. Of course, I've given one link of my choice. You can just Google and then pick whichever suits your liking. Okay, so that's the confusion that you need to be mindful of, and hopefully I've sorted out that confusion once for all. Password, I'll give it after the class in the group. I think I've already given the password for expert user in the, I don't know in which group, right? If I've given it on, I'll give it on both groups anyway. What level of Python knowledge is required? Do we need lean data structures to learn data structures and algorithms as well, or just basic programming? Data structures is required, and little more is also required. I mean, when you're learning lists, tuples, dictionaries, that's what is you're learning data structures. And you need to go a little beyond that as well. You need to learn functions. You need to learn about Python libraries, be able to work with Python libraries. And I mean, if you're aiming for the exam at some point in future, you also need to know a little more, something called as REST API development in Python. Yeah, I'll be sharing it. Every time after the class, I'll be sharing the latest version because I would have made some changes to on top of the previous one. Because it's getting built as we go along. Okay. Let's get started. How do I push this guy up? Where's my function key? Okay, we've got maximum real estate now. Okay, assuming that you followed one of those instruction manuals and you got it installed and you have it working, check the version using Python -V or Python -- version. Ensure that you are using Python 3 and not Python 2. And if you want to see which interpreter, right? Ultimately, it boils down to interpreter is nothing but a program which is taking the instructions from you and converting it into machine understandable instructions. So which interpreter you are using, you can check using which Python. Okay. Now, just like you do shell scripting, right? In Linux, you can give basic commands for performing your day-to-day tasks on the console directly on the CLI and get your work done, which is good enough. And you can also do script-based, which means you can write a script, put multiple instructions in it, store it as a .sh file, and then execute it. Right? So these are two ways you execute your instructions. Same is the case with Python. You can use Python in interpreter mode or CLI mode, command line interface mode, as well as in script mode. Right? If you want to use Python in interpreter mode, we have to invoke the interpreter using the command Python. Right? So I've connected to Python and the prompt changes to this 3 greater than symbols, which shows that yes, you are inside Python environment, Python interpreter. So here you can start giving your usual Python commands, whatever it is. So this is like your CLI. The script based we'll see in a minute. Okay, so we said that programming is all about giving instructions which manipulates certain data. Right, a raw data is given as input to the system. Your programs or code manipulates that and process it into certain output. Right, which means this data comes in different formats. So it's all about data. Right. And this data comes in different formats of different things. Right? So what are those different types that the data can come in is like, let's say you're dealing with, take your field, networking. Right? One piece of data that you're interested in, the names of the networking devices. Right? Within your organization, what are the names that you have given to your network devices? Right? So those names are like collection of characters, collection of alphabets. We have a technical term for this collection of alphabets. We call it as a string in short. String of characters. In short, we call it as string. String means a data type which can store textual data. Okay. So names, addresses, for all these things we use the type called as string, which stores data in a textual format. Then let's say that the network devices that we are talking about, we want to check how many interfaces are there, how many are enabled, how many are disabled, and so on. We are dealing with number. Right? Specifically, this number will be like 4 or 6, or you cannot have 4.5 interfaces, right? 4.5 interfaces or 4.1 interface. Right? So it has to be an integer. Right? Accordingly, this data type in technical terms is called as integer or int for short, int. Okay. Now let's say you have other piece of data, like you are talking about a specific interface, you want to know whether it's enabled or not. Right? So when you ask someone, is it enabled or not, you get the answer like yes or no. Right? So to deal with this yes or no kind of answers, we have a special type of data type called as Boolean type. Boolean means it takes and it accepts only true or false as values. Okay. Let's say we have we're talking about a person's height or the operating system version, right? Which looks it's like OS version is also like little deceiving. It can be nowadays like 15.6.7. Obviously, there's not a number, right? Though it is made up of numbers. So a better example would be what would be a in networking. Okay, let's consider a person's height, right? So he can be like 6.1 and 6.2 and so on, right? So this kind of data has a decimal point in it, right? We call it as decimal numbers or floating point numbers, right? In computer technical terms, we call this as float, the data type float. So string, int, bool, float, these are different types of data. Textual data, number data without decimals, number data with decimals, yes, no, or true, false kind of data. All these are called as basic data types. And we call them as basic because number, you cannot break it down further. Though you can break down further a string into substrings or characters, we treat string as a single entity. So in that sense, it becomes like a basic data. Strings are always tricky in all the programming languages. They are neither basic nor the complex data type. They lie somewhere in between. That's the case. The same case for Python as well. Okay. So far you're good. What is programming? Why we need to learn programming, and why we have chosen Python. How to go about installing Python. And once you get into the Python interpreter mode, we started talking about data, the data that comes in different formats, right? So we are talking about the technical terms which we use to define the data, which comes in different formats. It comes in a textual format as what we call as strings. So str is the data type. Then it comes as numbers, as integers, we call it as int. It also comes as floating point numbers, we call them as float. It also comes as true false values, we call it as bool. And these are all basic data types. Now there are also collection data types, which means so far I've been talking only about one router. Let's say we want to store details of 10 routers, right? What I'll use one of the collection data types called as list, a list of devices, right? So you define multiple devices in a single data type called as list. Okay. And you also, at times, you also need to store the data in such a way that there's a mapping between the attributes, its attributes and the values, right? So for example, like you are talking about the same router again, the router has make or manufacturer, right? Which happens to be Cisco, Juniper, this kind of thing. Then it has a model associated with it, which is like Cisco ISO or CSR 1000 and so on. It has a OS version, which is of certain version. And, it has a name. We give a name to it, and so on, right? So you see, these are all attributes: make, model, OS version, name. These are all values associated with it. Cisco, make, manufacturer is Cisco, model is this, OS version is this, name is this, and so on. So this also is a kind of data, right? So you see, that's why we call these as simple. These are collection data types, because we are not storing a single value in it, we are storing multiple values. Again, those multiple values can further be broken down and we can talk in terms of simple data types, right? For example, name, manufacturer, right? Cisco is a manufacturer, which happens to be a string. Model, Cisco CS1000, string. OS version, we can treat this as either a number or text, doesn't matter. Name, again string. Now, why I said that we can treat this either as a number or as a text is, though it looks like a floating point number, is we treat some things as numbers only if you want to manipulate them using some arithmetic operations. Otherwise, if you're not planning to modify them or if you're not planning to apply any arithmetic operations on them, it doesn't matter whether you treat something as a number or a string, right? So this is one such thing, like OS version. So the nature of this OS version is such that I can't say, yeah, I'll be multiplying this OS version with some other OS version. I'll be adding this OS version to some other OS version. So I don't have to perform arithmetic operations on this. So that's why I can either treat it as a number or I can as well treat it as a string. But let's say we're talking about a person's age, right? You cannot treat age as a string because age you will be using for certain calculations, right? Like you will check age with the country's restriction on age for different purposes, right? Voting rights, being able to enter certain places like pubs, bars, etc. So you need to be beyond a certain age limit. So you need to do some calculations on that. So in that case, if you treat that as a textual data, we will not be able to perform arithmetic operations. So we treat that as a number. Okay. Yeah. Now, looking at all this data, for us humans, we can easily understand, oh, okay, this is text, this is number, this is true, false, this is floating point, this is integer. But how do we tell computer? That's why we have these technical names, str, int, float, list, tuple. Right? Now, above, we have seen the names, a bunch of names like router names, person names, etc. All those are strings, are of type str, and they are strings. Then we have numeric types, right? Numbers, we have integer type, floating type. There is also a complex number type you can safely ignore for this, right? If you remember your school mathematics, there is one pretty complex topic called as complex number. Okay? So it is still used in scientific computing. So since Python is used for scientific computing as well, they have given a provision to represent complex numbers. So for all practical purposes, you can ignore this and safely go with int and float. Then you have sequence types. When we have to store multiple values of multiple values or multiple objects together, we use sequence types. Now there are two or three different types of sequence types called as list and tuple. What is the difference between list and tuple? Why we have two or three? We'll see that in a minute. We also have something called as a set. Okay. Then the other type, right, where you have attribute and some value, and you want to maintain this map. In such cases, we have mapping data type called as dictionaries. In some other programming languages, we call them as hash maps. Hash maps are nothing but they're made up of key value pairs. Key is the attribute, value is the its actual value. Okay, fine so far. We'll be dealing with data since we need to inform programming language in technical terms, what type of data we are dealing with, how to handle it. We have to give certain standard aims to them. Right? Then comes the concept of variables. Right? Now you have data, you have written code, the code takes the data and process it and it gives some output. But during this program execution, the data has to be stored somewhere temporarily. Right? We'll be accepting this data from the user, we'll be reading it from a file, we'll be getting it from a database in some way or other, or we'll be passing it from the command line while executing the program. Some way, some data will be passed to this program. This program has to take the data and process it, which means it has to store it temporarily during the program execution. Those temporary storage locations which hold the data are known as variables. Right? So variables are nothing but temporary storage locations allocated in memory which hold the data during the program execution. When the program is executing, variables are used to hold the data. Okay. So we can think of them like containers which hold some goods at any given point of time. Right? You are using a shipping container to send some food item to some place. So you stuff it with food. Then later you want to use the same container for transporting, let's say, some furniture. You take out food, you put furniture and send it. So depending on the situation, the variables, like let's say router 1, name of router 1, right? You are dealing with router 1, router name will contain router 1. Right? You are done processing router 1, you move on to router 2. Now the variable router name will contain router 2. So that's why this data which we store in variables keeps changing. And that's why we call them as variables, because they keep varying. Okay? So that's the concept of variables in programming languages. And variables are used as a temporary storage locations to hold the data during program execution. Right? Now, how do we create or how do we use variables? Variables, as we said, are named locations where the data, the actual data is stored. So we need to give a name to it so that we can easily identify what is it that we are storing in it. So it's like labeling, putting a label or putting a tag on the container. This contains food, this contains this contains that. Okay. So now I want to store the name of the router in a variable. Right? Can I call it as this? I can. There's nothing stopping me from doing it, but it doesn't make sense, right? So that's why while picking the names of these variables, we should not be stingy, even if it's if it requires you to come up with a long name, you can still go ahead for it. You need to choose descriptive names so that it suggests what does it contain. If I want to store router name, I'll type it out, router underscore name. Why I'm putting underscore here? Because spaces are not allowed in variable names. Okay? So typically we use underscore. If the name is made up of 2 or more words, I want to separate them out, I use underscore. So I pick a name, then you put a value in it using equality symbol. This is known as assignment operator. You chose a variable name, you put a value in it. Like let's say this is a branch router 1. So now my variable is created. It contains the value branch. I made a spelling mistake. Right? Branch router 01 at this point of time. How do I know? I'll type the name again. It shows me what value is stored in it. Of course, I can always throw away the old value and store new value. Now, if I ask it to display, it shows me the new value. Okay. So this is the way to create a variable. Pick a name, use the assignment operator equal to symbol, store whatever data that you want to store in it. So this value, this text goes and sits in a memory location, which is pointed to by this name. Now, within the interpreter, I can simply type this name to print the value. But the proper way of displaying or printing the value is using an inbuilt utility called as print. Print what? Router name. Okay. Of course, output is going to be somewhat similar, but this is a proper way of to be used for displaying content onto the console. What is console? Where you are working. Okay. Now, I said data comes in different formats. So you should also have a way to check what type of data is contained at any point of time in a variable. Okay. That's because I need to figure it out, because you see the way I created this this variable, I just picked a name. I'm just putting some text in it, right? So in other programming languages, like for example Java, you need to specifically tell whether if you are creating a variable like this, you need to tell what type of data it is going to contain. Whether it is going to contain a string, whether integer, whether floating point, accordingly, you need to tell upfront. In Python, it is not required. It is both good and bad in a way. Why bad? Probably you'll understand when you gain a little more experience as programmers. But for now, it is good. Because it's good for now, because dynamic, it uses a concept called as dynamic typing, right? I pick a name, I put a string in it, the type of this becomes string. Again, I take the same name, I put an integer into the same variable. Now, the type of this router name changes from string to int. Then I take the same name, I put a floating point in it. Now, from integer, this becomes float. I take the same and put true in it. Now from floating, it became Boolean. How do I know? We have another built-in, useful built-in function called as type. Right? Type does not mean that typing. Type means checking the type of data. Currently, it is Boolean. Yes, no need to define it. Now it is Boolean. Let's go back and put float and check type. See, it has changed to float. Let's put int, check type. It has changed to int. Let's put string, check type. It has become string. So depending on the type of data that you're storing, it automatically changes its type to that, which is not possible in other programming languages. So they are called as statically typed programming languages, which means the data type must be static. Before storing itself, you have to specify what type of data you're going to store in that, and only that type of data can be stored. If you declare something as, if you say that something is a string and you try to store number in it, it will give a compilation error. Okay, so Python is called as dynamically typed language because it dynamically changes the type of variable depending on the value stored in it. Well, for now it is good because we don't have to worry about declaring a type and then keep worrying about what type of data I'm storing in. But when you start writing complex code, this advantage turns to disadvantage because you tend to forget what type of data you are storing in these variables, and you use them in a different ways. It starts causing a lot of issues, a lot of errors. Okay, so one thing I would like to tell here is now Python has a concept of libraries. We'll be seeing the libraries again in a little more detail. It has one type. Libraries are like pre-written code for specific purpose, right? So let's say I'm inside this Python interpreter and I don't like all this clutter. I want to clear the screen, right? But my clear screen, clear or CLS commands will not work here because they are not Python commands. So there should be a way of giving OS level commands from Python interpreter, right? It is there. Either we need to do that or exit Python interpreter, clear the screen, again get in, right? Which is a tedious process. Instead, what we can do is we can import, we can borrow a module or library called as OS. As the name suggests, OS library can be used to perform some OS level operations, right? Since now you see this print type, I use them without importing anything. That's because they are part of Python's core, Python's standard library, right? Though this OS module, for instance, it is shipped. It comes with a Python installer, but it is not part of the standard library. So that's why if I want to use something from this library, I need to import it. So I import. We'll again be getting into these details. For now, just for your understanding, I made a quick reference to it. Right. Now, OS module, we can call it as module or library, has a utility or method called as system, which can be used to give system level commands. For example, like mine, clear. So clear is a OS level command to clear the screen. But I'm inside my Python environment. To be able to use it, I have to first borrow the OS level code which is written, and then it has a function called as system, which means that using this you can send system level commands, and then I pass the actual command. When I do this, it has cleared the screen and I'll come back. Then we have covered all this. We have not covered this. Yeah, you can. We covered it directly. Host name, make is also this OS version. I'm treating it as. Now, how do I know whether I'm treating this as a number or a string? You see the way I've represented this, and this. Right? This is a string, so I put in double quotes. This is a string, I put in double quotes. This is a string. How is this a string? Because 9300B is not an integer, right? So we treat this as a string. I put in double quotes. Only this, and this, I don't put in quotes, right? Directly I give it. So these become numbers. If I put in quotes, then this becomes string, right? And these are, I don't know why it's coming like this because of typing. These are both single quote as well as double quotes. Both are accepted. There's no hard and fast rule that you have to use only double quotes for representing strings. Okay. And print function, type function we have seen. Okay. Now we said, yeah, we have data, we are doing some manipulation. We'll be storing temporary variables and then performing some operations on them. Right? So manipulation is nothing but performing certain operations, which means you need certain operators who can perform these operations. Right? So those operators are broadly classified into these categories, right? Arithmetic operators, then assignment operators, comparison operators, logical operators, and special operators, right? Let's see what each of them are. Arithmetic operators are typically used to perform arithmetic operations like your plus, addition, minus, subtraction, into, multiplication, slash, division, right? These are basic, which we already know. And these are the names, these are the symbols which can be used, these are the names, and these are the example values. Now there's something more here, right? Double slash. And the double slash performs floor division. Right? Single dash performs division, double dash performs something called as floor division. Let's see what this means. You see, I did 10 by 3, I get 3.33333. I do 10 by 10 slash 3. I get 3. Right? Because this part, whatever follows, because this is never ending. Right? So this part has been chopped off and only this part is considered. Okay, this part is clear. So it's like you have A is equal to 5, B is equal to 6, right? A plus B, addition, A minus B, subtraction, A into B, right? Multiplication, division we have already seen, floor division we have already seen. Right? Now you also have like exponent. Let's say you want to raise 2 to the power of 3. Right? 2, put star star instead of 1 star, which represents multiplication. You put 2 asterisk symbols. Right? 2 raised to the power of 3 is 8, and so on. Okay. So you see, I'm using my Python interpreter also as my calculator. And so that is just one of the small features of this thing. Okay. Not only this, you can give any other Python commands also here. Okay. So these are your arithmetic operations. Then you have your assignment operators. Right? Assignment operators we have already seen while creating the variables, or here also for that matter. Right? I'm creating a variable, a storage location called A, and I'm putting the value into that storage location. So this we call it as assignment. A assigned 4. Now A becomes 4. Now let's say I want to add something to A and put the result back in A itself. Right? Now this is like age. Currently some guy is 18. In the next year, right, his age has to be incremented by 1. Right? And when he becomes a year older, I won't create another variable called as age 1 to store the value, right? I store in the same value, right? So let's say age is equal to next year age, whatever is the current age, plus 1. It becomes age is equal to age plus 1. Right? You understood this expression? We created a variable called as age, put the value 18 in it. Now, next year, we want to find out how old will this guy be. So we take age. First, we take age, add 1 to it. Now, the result of this expression, I'm storing in this variable itself. Right? This part is clear. I want to put back into the same value because it doesn't make sense for me to create another variable and store age in it when I already have age. So now if I ask it to show age, it got incremented by 1. I do the same thing again. Now age becomes 20. Right? So you see age is equal to age plus 1. Though it is like short, it looks a little something out of the place, right? So what these guys have done is they have come up with something called as this concise operator assignment operators. So age is equal to age plus 1. I can simply say age plus assign 1. This means that take age, sorry, this is 1. This means that take age, add 1 to it. The result, you put it back into age itself. Okay. So these assignment operators are a simple way to shorten this kind of expression. And where you have to take a variable, perform some operation on that, and put the value back into this operation. In such cases, we use a better notation. Age plus assigns 1. Take age, add 1 to it, put the value back into this variable itself. Okay. So these are the assignment operators. Yeah, these we have covered. Arithmetic operators, and I've given some simple exercises. You can practice them. Of course, there are ample number of resources out there for you to learn Python. Even on the DevNet Labs section, also you have some free tutorials on Python, along with your execution environment, which means you don't even need VM. Simply out of your browser itself, you can practice simple coding, right? So these are the assignment operators that we are talking about. Equal to is the usual assignment when we are creating a variable, putting some value into it. Plus assigns is addition assignment, which is equivalent to A is equal to A plus 1. So we can simply say A plus assigns 1. The same concept holds good for all other operators as well. You want to subtract something from one variable and put it back into it. You say age minus assigns whatever number, 1. Okay. So that is just a simple feature or facility that is given to us. Okay. Then comparison operators, right? Most of the time you have data, you are like checking, right? Whether comparing, you are checking by comparing, right? So you need some comparison operators, like whether your vendor name is equal to Cisco or not. Right? So now for checking the equality, ideally we will use equal to symbol. But that equal to symbol is already taken up by your assignment operator. So we use double equal to. Right? And this exclamation equal to is treated as not equal to. Right? Now 3 double equal to 5, it gives us false because 3 is not equal to 5. 3 not equal to 5, this gives us true. Yeah, that's a good link. Okay. Now let's say you want to check, compare whether something is greater than something, something is less than something, something is greater than or equal to, right? Let's say you want to perform an update on all those routers which currently have certain OS version. So which are below certain OS version. So all those devices whose version is less than 14, you want to take some action on them. Right? So in such cases, you will be using these comparison operators. Now, these comparison operators, right, they always return Boolean values. Right? Because you're asking a question like, is A greater than B? The answer will obviously be yes or no. Right? If I'm asking a question like, is A less than B? And the answer will be yes or no. Right? Of course, if you know the values of, or like, let's directly take the values, right? Is 3 less than 4? Yes, right? So true. So they always, these comparison operators always result in Boolean values. That's why we use them in something called as conditions to check whether some condition is satisfied or not. Okay. And then you also have some logical operators. Let's say you have two comparison operators to be combined, right? You 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 want to perform some action on all those routers whose version is below something. Not only that, whose vendor type is also Cisco. Only in that case, only on Cisco routers which are below certain OS level, let's say you want to perform some action. Right? So you have two conditions. One is the OS being below certain version. The other one is vendor being something. So in such cases, we will use and. In this case, both the conditions have to be satisfied. The OS has to be below certain version. The vendor has to be of certain type. So we have to say expression 1 and expression 2. Both expressions should be true. Only then the entire expression will become true. Let's say either one of the conditions is enough. We use or. Either A should be true or B should be true. And not is like simply negating whatever A says. Right? If A is true, not A is false. If A is false, not A is true. Okay. Am I going too fast or is it okay? Is it making sense? Will you be able to understand these concepts when you start reading up from other sites? Okay. Okay. Now there will be some situations where you have to check the identity of this thing of some objects. Right? In such cases, we use is and is not. Right? Like I'll show you an example when this makes a difference, is and is not, and in and not in. These are called as membership operators to check the membership of some element in some collection. First, I'll show you. No, we'll continue. Yes, you can practice and ask doubts in next session. Okay. Now let's say we have right. There's a function called as ID, which gives you the detail of the memory location where this A is stored. Right. So this is that memory location where the value 3 is stored. Now let's declare another variable B is equal to 3. Check ID of B. Oh, it's the same, right? What happened here is you have two variables, A and B, two different variables, A and B, which are having the same value. So what Python has done is, instead of creating two memory locations, it has created only one memory location and put the pointer pointing to two different locations where this value is stored. Okay. Let me show you. I don't have my pen handy, so bear with my drawing. Okay. This is there's a variable A. This is variable B. Right. Now you said A is equal to 3. So what it has done, it has created one memory location where it has put 3. Now 3 is now pointing to another location where A is stored. So that's how A has become 3. Now you declared B is equal to 3. Instead of creating another variable and putting 3, what it has done, it has simply taken this and pointed to this. Okay? That's why this location, this ID is coming as same. This is same. A and B both are two different variables, but they are pointing to the same memory location. Okay. Now we are slightly jumping here. Let's say we have a collection of objects. We represent it like this. Devices is equal to 1, 2, 3. This is how we represent multiple values. check ID of dev something, check ID of dev 1 or 2. So you see, this is different. This is different. This is different. So in case of primitive values, right? In case of primitive values like integers, strings, booleans, etc., Python behaves this way. In case of complex objects like this is dev, this is dev1, though they are storing the same values 1, 2, 3, it puts in 2 different locations. Right? So in these cases, the is and is not will make a difference. Now, A and B are pointing to same memory location. So if I say A is B, we get true. Whereas dev and dev2 are pointing to, though they contain same values, they're pointing to different memory locations. So when we say dev is dev2, we get false. Okay, so those are the identity operators. Yeah, if you change value of D, this thing changes. It creates, because if the value changes, it has to create a different register and then point to it. Right? Value changes. Okay. Now you see you have this dev as a collection item, right? Now you want to check whether some element is inside this or not. So that is where the in not in membership comes in. Membership operators come into picture. So 2 in dev. What will be the result? True. 4 in dev, false. Right. So that's how the membership operators work. So these are useful in some cases, like let's say you're dealing with multi vendor projects where you maintain a list of all the vendors, and let's say a new switch comes in, new vendor device comes in. So first you want to check whether that new vendor is already in the list of existing vendors or not. So in that case, you'll be using this in kind of operator. So it will be fixed for 5 or 10 for the machine, for all the machines. No, these IDs, I don't know what you mean by, but it will not be fixed for all the machines. How much are we going to cover today? Why, you already had enough? Okay. Okay, I guess we covered operators, right? Which example in real time? Yeah, the membership operator can be used in that case. IDs, normally we don't bother much about IDs. So in some cases we want to, I mean, we should be careful, right? There are 2 ways to check, right? A equals B. Of course, no value changed, right? OS dot and A is equal to 3 B is equal to R. Right? Device 1 or vendor 1. Cisco. Now vendor 1, this will be true. In this case, since it is a string, is also going to be true because both of them point to the same location. But for complex type, so in this case, in the case of primitive data types, you can use either double equal to or is. But for the collection data types, you should not use this is, because then the value, the result changes. Right? So that's why I'm highlighting this difference, how it works internally. Well, next session day and time has already been fixed, right? It's Wednesday 8 to 10, Mondays, Wednesdays, and Thursdays 8 to 10 p.m. Okay. Let's say you have vendors, list of vendors. Okay. New vendor comes in. You want to first check whether new vendor, new underscore vendor in vendors. It is already there. Sorry, Monday, Wednesday, and Friday, alternate days. If I had said Thursday, then sorry, I mean, my bad. Oh, yeah, Monday, Wednesday, Friday. Okay. Okay. Well, we have not covered any major things for you to do hands-on, but yes, I mean, you can brush up your concepts so that try to be a little ahead of me so that you'll be able to appreciate the things which are being discussed and get the doubts clarified. So I guess a lot of people are wanting to stop. So we'll stop here. You can take any questions or